So in the previous video, we've seen how earthquakes and volcanoes happen on the Earth thanks to Vibes of Cosmos, and continuing in book number 5, this is page 75, continuing with the earthquakes, right? It says here seismic areas and favorable conditions. Let's continue to dive in more about the science of this world. Areas with sea currents, with spongy soils, and narrow cavernous places in their subsoil. As we all know, there's so many places like this on the Earth, with underground grooves, have a higher probability of a larger earthquake. And it makes sense, it happens in the real world all the time. Spots with spongy subsoils know many earthquakes in seasons of no rain or a lot of rain, spring and autumn, as summer due to heat and drought, and winter due to ice and periods of calm. During periods of heavy rain, there is a lot of compressive force in a small space inside the subsoil. The water takes up a lot of space and does not leave the necessary space for the incoming air, which eventually exhale from the subsoil violently, as we've all seen in documentaries, either under ignition when it comes to dry fumigation, or with moisture if it is liquid. Remember, there's dry and wet fumes. It's with moisture if it's a liquid, or it's with ignition and boom, explosion if it's dry fumes. Now, when warm vapors flow into the soil, the outflow of air due to the moisture creates condensation and cold. Depending on the size of the cloud of fumes, on its qualitative composition, and on the relief and shape of the subsoil and cavities, we have strong or milder ignitions, explosions of this cloud underground, and therefore strong or mild earthquake. Remember, the earthquake is what we feel on the surface because of the explosions that happen underground, because of the wet or dry fumes. If it's wet, it's moisture. If it's dry, it's explosion, ignition. Now, types of vibrations, you can see when the earth shakes and crumbles on the surface, it's the vibration that comes from below because of the explosions. Depending on the way we have the accumulation of fumes underground, we have different types of vibrations during their combustion. When this gaseous stream is large and wide, when it ignites, there is a horizontal vibration, which is more frequent, while in areas where we had storage of the fumes in depth, we have a vertical vibration. In areas where the incoming wind with the fumes has difficulty passing and does not find a way out, we have greater vibrations. It makes sense, more violence. Duration of seismic activity. This is also important. An earthquake does not stop immediately, but the phenomenon is prolonged with aftershocks for about 40 days and up to 2 years. That's why you have several areas in the world where you have constant earthquakes. It's because of these conditions that give that are present with the moisture wet fumes or the dry fumes. Now, this is because the source that gave the vapors dry or wet, very important, dry or wet, and gave the impetus to the wind, there could not consume all its matter at once. So it doesn't consume everything at once. It takes time. That's why you have from 40 days to 2 years. That's why several places in the world are more frequent to earthquakes across a period of time. Until all the remains of this matter are consumed, the vibrations continue to decrease. The locality of the earthquakes depends on the subsoil space available for the burning gas to escape. Because it doesn't escape all at once, and it keeps on having explosions, we have constant earthquakes. Now, that's why in some places the earthquakes are low. So we have, like, on the Richter scale, 3 something or 4 something earthquakes. So if they're below 5, they usually don't pose a threat for infrastructure. Now, summary regarding this whole thing. I like also the pictures used here. Summary regarding the earthquakes and everything about that. In other words, the cause of earthquakes is the same that causes comets and meteorites. Comets and meteorites were explained previously to this. The dry vapors with low atmospheric pressure, and when the wind helps them, rise to the ionosphere, and after being compressed, they descend and ignite in a diagonally downward direction as a composite of the straight motion due to the density and refraction up-down and its tangent circular orbit of ionospheric gas currents. This is a bit of mathematics, but it's the real world, so don't care. Not a big deal.
which currents are created due to the contact of the upper layer of the ionosphere with the superlunar superlunar, I think this is like misspelling, that rotates, creating the electromagnetic field below. Remember, it's the electromagnetic field that rotates. It's not the Earth, it's the electromagnetism. So everything is electricity and magnetism, and that's what rotates all the time. That's why NASA then took that and they portrayed the globe with spinning ball, curved water. When the wind does not help the vapors to rise and combine with high atmospheric pressure, it pushes them through the porous soil downwards towards the subsoil. There they sometimes condense and ignite. We could finally say that all these phenomena, comets, shooting stars, meteors, celestial colored flares, black or blue flares like gaps on the sky, the intensity and undulations of the light of the aurora borealis, seismic vibrations, landslides, and volcanoes are purely meteorological phenomena that happen all the time on Earth, and because of the electromagnetic field. These phenomena depend on the atmospheric pressure, the temperature, the direction and temperature of the winds, the percentages of wet and dry vapors, very important, that dual classification in the air, and the morphology of the ground relief and the subsoil. Their prediction is possible, especially with the modern means of collecting the above data, because that's why we can then predict these things, because all this is measurable with data, and that's why they happen on a constant basis, because we live in an electromagnetic field. Also the study of geology with the study of the moon is possible and offers us a lot of information in relation to the soils and their morphology, as well as the qualitative composition of the subsoil by region. The atmospheric pressure exerted by the ionosphere on the lower layers of the atmosphere acts as a lever for the presence of all the above phenomena. It depends on the intensity of the electromagnetic field in relation to the position of the sun and the moon on the upper level, which we saw how it works analytically in the tides chapter. There's a chapter about tides, and they actually explain how the sun and moon, they move all the time, and the interaction of the electromagnetic fields of the sun and moon, which are actually refractions of the black sun, electromagnetism. So that's why we have this interaction of, it's a game of interaction of electromagnetic forces and fields that move constantly in a pattern. As we saw in the fourth book, the tides, there's a chapter of the tides in the fourth book, where we have the natural respiration of the earth in relation to the water. So here we have the natural respiration of the earth in relation to the gases. So the same that we have the cycle of water, which we actually studied in primary school. In this chapter, in book 5, we learn, because of the natural respiration of the earth in relation to the gases, the wet and dry fumes, we have the earthquakes, and sometimes we have lava coming out, etc. So the phenomena we saw are therefore the results of this operation and are inevitable. And I hope that this makes sense, because like once you read everything that's explained, in this case in book number 5, it's so easy and so simple. It's pure science, and it's the reality of the real world. You just have to take time to study. I mean, you're nobody's gonna come at your door and say, hello, I want to teach you this. No, it's up to you. If you have willpower, you spend your lifetime, you spend part of your time in a day, whether that's like minutes or half an hour, 1 hour, and you literally study the same as you would study a foreign language, or you study something to do manually. I know, it's just up to you, really. I mean, I didn't know about these things. I had to study them, to research, to read. So it's simple as that. See you in the next video.